Okay, so on this one, we are wanting to find the surface area and the volume of a right triangular prism. See how this is a right triangular prism? It's got a triangle on the top and a triangle on the bottom. Remember, a prism is always a shape that has it's a three-dimensional shape that has same shape, top and bottom, straight sides in between. So see how it has a triangle on the bottom, triangle on the top, and then straight sides in between. So it's a triangular prism. Same shape, top and bottom, straight sides in between. That's a prism. So it comes up straight, same shape, top and bottom. So it's a triangular prism. They're going to lead us through step by step. And so first off, they want the area of the two bases together. So they want us to find like this triangle base and this triangle top, the bottom and the top added together. What are the area of those added together? Well, you know how to find the area. This is a triangle, right? Area equals a half times base times height, because it's a triangle. All right, and what's the base and the height? Well, we can see down here that the base and the height are the 12 and the 11. How do we know their actual base and height? Well, because they meet at 90 degrees, don't they? So that's perfect. Base and height always have to meet at 90 degrees, don't they? Remember, because like if you want to measure your height, you have to go straight down to the ground. You can't go diagonal. That's not height. So height and base must meet at 90 degrees. So this is base, this is height, or vice versa, it doesn't matter. Those two are base and height because they meet at 90. So it's very important they gave us this 90. If they didn't give us this 90, we wouldn't be sure which side, where base and height are. We wouldn't be sure those are really the base and the height. But they are, because they meet at 90 degrees, don't they? So those have to be base and height. They meet at 90 degrees. Okay, so that's the top. All right, that's the top triangle, and then the bottom is the same. Bottom triangle is the same. It's also 66. So add those together. What is that, 132? So 132 would be the two bases together. Top and bottom are the same. They're both the same triangles. Okay, good. Next part, the lateral surface. So there's that word lateral. Lateral, again, lateral means the sides, not the bases. Not the top and the bottom, right? So it means find the sides. Well, what's involved with the sides? The sides are three rectangles, aren't they? Right? The sides involve three rectangles. So we're going to have to find the areas of each of those three rectangles and then add them up to find the total lateral surface area, the area of all the sides. So let's, sorry about that. Let's start with the right side first off. Right side rectangle. So right here, there's the right side rectangle. So rectangle is just length times width, as you know. So that's just 29 times 11, whatever that is. I'm getting 319. Oops. Sorry, I'm just scribbling on those threes. 319. So we got that. That's the right side rectangle. That wasn't too bad. And then let's go for the let's call it the front. The front rectangle. By that I mean this right here. Yeah, better erase the red stuff. Yeah, it's getting a little confusing. So okay, so this front rectangle right there, and what's that? Again, that's going to be length times width, and bring this 29 over right here. This 29 is right there as well, isn't it? So it's 12 by 29, the two sides of that rectangle. 29 by 12, 12 by 29. See what we get, 348. 12 by 29. Two sides of the rectangle. So that's the front rectangle. So we've got the right side rectangle here. We've got the front rectangle, trying to do all the sides. And now one more, we've got that back. That's going to be the trickiest one. We've got that back rectangle. Which is, again, it's length times width. It's a rectangle. Let me get rid of these so we can see it clearly. So the back rectangle back here. So length and width, what are the length and width? Well, the width is right here, isn't it? And we don't immediately know what that is. And then this is the length, the 29 is the length. Yeah, so the two sides of this rectangle are 29 by, I don't know. See, I don't know that width. I don't know the width of the back rectangle. How am I going to find the width of the back rectangle? You can see it. It's Pythagorean Theorem again, isn't it? You see it there? So it's going to be what? It's going to be a squared plus b squared is c squared to find the width. So this is like a, b, and this is c, because that's the side across from the right angle. Remember, C is always the longest side in a right triangle. It's the side across from the right angle. So again, it's very important that we observe this right angle. That makes this a right triangle, which means we can find the width back there. So use the Pythagorean theorem. So that's going to be 11 squared plus 12 squared is W squared, isn't it? Because the C is the W, is the side across from the right angle. So use your calculator. 121 plus 144 is W squared. This is 265. Add those up on your calculator. It's W squared, and then root it. And so we get the width. Let's see, I'm going to use my calculator here. I'm getting 16.2788. Now, we should use 4 decimal places. Why? You might say, Mr. Turner, they only want 2. Well, yeah, they only want 2 in the end, but you always have to use more decimals in the middle of the problem than they want in the end. So if they want 2 in the end, you better use 4 all the way through the middle. So use 4 decimals. That'll make the ending 2 decimals accurate. So use more in the middle than they want in the end. They want 2 in the end, use 4 in the middle. Okay, so, okay, what do we do? That's width. Let's go back to the rectangle now. We were trying to find the rectangle, the back rectangle. So it's length times width. The length is 29. The width now is this number, this 16.2788. You with me? That's length times width. We just did all that work to find the width, so we could plug it in to find the back rectangle. Length times width, use your calculator. It's going to come out to be something. I'm getting, oops, getting a little sloppy here. 472.0858. So there's the back rectangle. And so now we add those 3 up to get the total surface area. You tracking with me? I mean, to get the side. So it's getting to be a long problem here. So the lateral sides, what do we got? We've got the right. I'm doing piece by piece. At the right, which was 319. We've got the front. Above, which was 348. And we've got the back rectangle, which was 472.0858. Add those up to get the total lateral, the sides surface area. I'm getting 1139.0858. So round it, cut it right there. It'll be 1139.09, right? It'll round up 1139.09. So that was a lot of work. So we had to find the three sides. To find the sides, the lateral surface area, the sides, not the bases, we had to find the three rectangles. So we had the rectangle on the right, just length times width, 29 times 11. We had the rectangle on the front, that was just length times width, 12 times 29. And then the back rectangle, again, length times width, but we had to find the width, the Pythagorean theorem, and then plug it in, length times width. We got the back, add those three up, right, front, and back, get the total. And now, on this next question, they want us to give them the total surface area. Well, that's just going to be these two guys added up. Again, I encourage you to submit one answer at a time. I'll make it a lot easier for you. Just put in that first answer and submit. Make sure it's right. And then put in the second answer and submit. Make sure it's right before you go on. It'll make it easier. That way, if you make any mistake, you can fix that before you go on. And now total surface area, that's just the two bases, which is the top and the bottom triangles, top and bottom triangles. And then add to that the sides, and you've got the total surface area. Just want us to add those together. So I'm going to do that. I'm getting a total of 1271.09 total surface area. And then their final question completely changes gears. Find the volume. So again, that's a total change in gears, isn't it? All these three questions were about surface area, right? The bases, the top and the bottom triangles, and then the lateral, which is the sides, the three rectangles on the sides, and then add all those up to get the total surface area. Like if you wanted to paint the outside of that piece of cheese, looks like a big piece of cheese or something, triangular, right triangular prism. And now volumes, now it's like we're filling it up with water, or like how much total volume of cheese is there, or it's a piece of cake or something, right? Piece of pie or cake. How much total volume of cake or cheese is there? Total volume, fill it up. So now we need to go to the volume formula, totally different than the area formulas. So how do we find the volume? Well, go for a prism. Here we have volume of a prism. Remember, we've had this before. How do you find the volume of a prism? Well, it's base times height, where B is the area of the base. So here's a triangular prism, which is exactly what we're looking at. That's what we have is a triangular prism, right? We have a triangle on the ground and a triangle at the top. What's the volume? Area of the triangle base times the height. That's how you find the volume of a prism, right? That makes sense. Look at the diagram over here. The more it makes sense, the more you'll just naturally know what to do. Because this is a prism, a big Rubik's Cube, meaning it's the same shape all the way up and down. That's what a prism is. Same shape. See how this is triangle all the way up? Or this one is rectangles all the way up. This one is pentagons all the way up. This one's hexagons all the way. That's what a prism is. Same shape all the way up. So what do you do? Well, if you have the same shape all the way up, it's obvious. You just find out how much is in one layer. Like there's, what is there here? 5 by 4. There's 20 cubes in one layer, and then just multiply by how many layers high it is. Right? You just say 4 layers of 20. There's got to be 80 cubes there. Find out how much is in one layer. Well, that's the base. And then multiply by how many layers high. Multiply by the height. So that's what we need. Triangle base times the height to fill it up. Okay, so let's go do that. So the volume then, is going to be area of the triangle base, times the height. Area of the triangle base times the height. Well, what's the area of the triangle base? Well, it's a triangle. So a half base times height for that. So the volume is a half base times height. let me kind of squishing this in here. Is half base times height times the overall height of the thing. Now there's two heights going on there. That again, that can be very confusing. Let me clarify that for you. We have two different kinds of heights, right? As we go back, let me erase what we've done so we can just see it more clearly again. So you look at this shape, we have the triangle base. Here's the triangle base, which has a base and height on the ground of 12 and 11. So that's these guys. Whoops. All right. That's half times 12 times 11 times the overall height of the object, which is right here, 29. That's the actual three-dimensional height of the prism, 29. Do you see the difference between those two? That's really important. I know that's often a confusing point for people. So we have the base and height on the ground. That's when we're doing the triangle base on the ground, base and height on the ground. And then we multiply by the overall height, three-dimensional height of the prism, which is the 29. So that'll be our volume. Multiply those together on your calculator. I'm getting 1914. 1914 is the overall volume of that shape. There we go. Questions I can answer on that one. Is my steps making sense? Anything I can clarify on my steps there?